All right. I think we're live. No guest today, just me. So no plan today. Let's get into open space. Of course, I want to regale you with the virtual star party that we had last night. We had one blast from the past. Shah Ahmed, who is from Malaysia, and he used to do a lot of the virtual star parties with us, and he was showing Venus in the daytime just a couple of degrees away from the sun, which was just absolutely incredible. It's just this thin little slice of Venus, and you should definitely check Shah's Twitter feed. It's Shah Gazer, Shah Gazer on Twitter. Just absolutely stunning pictures of Venus that he took yesterday during the daytime. He broke his record for the closest he's ever captured Venus to the sun, and we got to see it live. We also got some shots of the moon, and of course, when the moon is up, you don't get to really see anything else. So the rest of our deep space stuff was mediocre, but and then we had Linda, and we had two Davids joining us. So again, if you want to catch up, just watch last night's episode of the Virtual Star Party. The other thing, of course, was we had the successful launch of Crew Dragon, the DM2 flight to the International Space Station. The astronauts have arrived safely at the International Space Station. They have named their spacecraft Endeavour, which I think is, I don't know, it feels like that name's already been taken, but I understand why they did it. But still, it's incredible to see the progress happening at this point. That was a pun. But anyway, let's go ahead and hit any questions that you have about space and astronomy. I am at your disposal. I have no plans at all whatsoever. I am working on an episode about the flight, but apart from that, I have, and then I'm going to work on a question show, and I've got a couple of other interesting topics that we're going to probably tackle this week. So hopefully we'll have some more good stuff. So again, hit me with your questions. I got no questions so far, I don't think, unless someone's asked me an interesting question. I'm just going to ramble until someone has an interesting question. Arjone, save me. I'm trying to think what else has happened that's really interesting this week. What happened today? Right, so the American Astronomical Society is having their virtual conference, and of course, we went to the Astronomical Society, meaning the one in Hawaii, back in January, and it was a great time. We had a lot of fun. Of course, we've been continuing to put out the content that we got there, but it's interesting to see them do another version of this conference completely virtually. And so the news is coming out like crazy. We got some really interesting news. Black holes blasting out jets. The European Space Agency Solar Orbiter is going to be flying through a comet tail. We learned about the meteor impact that wiped out the dinosaurs, created a vast underground hydrothermal system, and apparently it struck the Earth at precisely the wrong angle to cause maximum destruction. So there's a bunch of great news, and so we should be, like, if you're interested, like, if you haven't already, sign up for my newsletter, because this week it's probably going to be a gigantic newsletter, because there will be dozens and dozens of interesting space stories that have come out this week. So all right, now I got a bunch of questions. So, UK Bengali. What could possibly happen if the universe suddenly stopped expanding? Could space-time freeze? Could it cause a universal event horizon? So this was the question, I mean, will the universe stop expanding was a question that astronomers used to want to know, because when they thought about the expansion of the universe, and again, right, it is not an explosion, it is this expansion of space in all directions. It was more dense in the past, it's less dense today. But within that, you've got all of these galaxies and galaxy clusters that are moving away from each other. And so galaxies wanted to know, would at some point, right, as these galaxies were spreading apart, would their mutual gravity pull them back together? Or would the universe just continue expanding forever and sort of slowly coast to a halt until it finally stopped? And so they did these really precise measurements of the expansion rate of everything. And what they found was not only is the universe not coasting to a stop, it's actually accelerating away from each other. But if it did coast to a halt, right, it wouldn't stop space-time. It would just be that the things would be stopping to move away from us as quickly. And so it wouldn't really have any impact on space-time itself, and you definitely wouldn't get a singularity. Now, if it started to come back together again, then you would have a very interesting situation happen, as all of these galaxies and galaxy clusters are starting to come together and form, and you essentially return back to a state that was similar to the Big Bang. But the thing that's really important to understand as well, though, is that you've got space-time itself, which is expanding and carrying away all of these galaxies. But then you've got the galaxies that are embedded within space-time, and they're moving around based on their mutual gravity. And so these are all kind of separate issues. But no, you wouldn't space-time wouldn't stop, and time wouldn't stop. You would just get to this point where everything was sort of perfectly balanced and coasted to a halt. Kim Barron, any plans to do solar observing? Then you have to stay up as late. Yeah, we did some solar observing in the star party. Shaw had a hydrogen alpha scope that he was trying to spot prominences on the sun, and we didn't see any because mostly the sun is like the quietest it's been in a long time. But we got to see just the surface of the sun and got to see the shape of the sun in the star party. And we'll definitely do that as more astronomers bring really great telescopes. We'll definitely try to see that. Dawn Archangel, if standard candles aren't for sure, then how do we know the universe is expanding? Well, so there's two separate parts to that, right? There is the standard candles. We know that most of the standard candles are very accurate, and the most accurate one of these is this idea of the Cepheid variable. And these are these stars that pulsate in a very regular way, and they pulsate based on essentially their intrinsic brightness. And so when you watch and calculate how one of these stars is pulsating, you know how bright it is, and by looking at how bright it is now, you know how far away it is. And that process is incredibly accurate. It's used to calculate distances inside the Milky Way, and it's used to calculate the distances to other galaxies. So based on that, plus all of the other methodologies, there's no question that the universe is expanding. The question is the additional standard candle of these type 1a supernova. Those are the ones that some astronomers think that they might not be as precise a standard candle as astronomers used to think. And so, we've talked about this a bit before, that the idea of a type 1a supernova is you've got a white dwarf star that's orbiting around a regular star, and the white dwarf star is feeding material. And when it hits this very important number, 1.4 times the mass of the sun, it's called the Chandrasekhar limit, the star explodes. It's just like it's too compacted down. It can't act like a star, and it detonates as a supernova at this exactly 1.4 times the mass of the sun. And so astronomers were looking for this, because again, if you know the star is exploding, you know how much mass is in the star, the whole thing explodes in one moment. You know how much energy is being released, so you know how bright it would be intrinsically. And so when you look at a type 1a supernova and say, oh, here's how bright it is, then you can calculate how far away it is. And it was always thought to be that these type 1a supernova were always exactly the same brightness, no matter how far away they are. And this was this way that you could measure your distance to them. And suddenly, the new possibility, or the interesting discovery, was that in fact, once you start to find these type 1a supernova, which allow you to essentially spot galaxies that are really far away, they are farther away than current models of how the expansion of the universe should go. And so based on that, astronomers said, the expansion of the universe is actually accelerating. But this depends on type 1a supernovae being as bright as astronomers think they are. And so the new research, the new idea is that actually the brightness of a type 1a supernova depends on the ingredients that it's feeding on, right? And so if your supernova, if your white dwarf is feeding on elements, primordial elements that are happening, closer to the Big Bang, that's going to be different from a type 1a supernova, from a white dwarf that's feeding on more mature stars with heavier metals and things like that. And so it might be that the brightness of these supernovae are different at different times in the universe. And now suddenly, what you thought was a standard candle, you actually can't use it as a standard candle. And so now the possibility is that if you can actually make this fit, then suddenly dark energy just goes away. That we thought the universe was expanding or was accelerating, but it turns out that actually that stars that are farthest away have a different brightness from the stars that are closer to us. And that explains why they have these different brightnesses. And if true, that would literally just erase dark energy, that we thought there was such a thing as dark energy, and now there isn't. And that's how science works. And of course, the solution to this problem is more data. You need to come up with better telescopes that can do a more precise job of measuring all of these objects. And then the other way that you solve this problem is with this idea of multi-messenger astronomy. So right now, most of the observations that astronomers use is in various kinds of the electromagnetic spectrum. So they'll look at X-rays or visible light or gamma radiation or radio waves or ultraviolet. But those are all just the same thing. They're all just photons. But suddenly, if you can observe neutrinos, or more excitingly, and this is the big one, is that if you can observe gravitational waves, now you essentially have two ways to independently measure the distance to one of these events. And so this is why, for example, the kilonova that happened in 2017 was so exciting, was because astronomers watched the thing explode and saw it in the visible light, but they also detected it using gravitational waves as these two neutron stars were spiraling in and collided with each other. And now you've got this independent detection between the two, allows you to really triangulate on what this event is. And for example, one of the interesting side effects of seeing the kilonova was we, for the first time, knew for sure that light and gravity move at precisely the same speed. The gravitational waves arrived and the light arrived at almost the exact same moment, or essentially had traveled at the same speed to get to us. And so, in theory, we'll have to go back and do the exact same thing. But now we'll have to look at these type 1a supernovae as they go off, and hopefully there'll be a way we can see them with gravitational waves and use that to know that, yes, indeed, that galaxy is as far away as we think it is. Therefore, dark energy is a thing. But maybe dark energy won't be a thing. All right. So more research. I mean, this is what's fun, right? This is a mystery. Let's solve this mystery. More data. There's a new observatory coming online called the Dark Energy Survey. Its only job is to help try to pin down dark energy better. The W-FIRST telescope is going to try to help pin down dark energy better. Sergusi, hey Fraser, if possible, would you give advice if there's an easy way to determine the distance to another planet of our solar system on a given date? I don't have an easy way. I mean, it depends on what your method is. I know that there are some Python libraries that you can use, that astronomers use to calculate orbits in the solar system. And there are so you can essentially run those orbital tables into the future and predict the distances of the various planets. You could use something like Universe Sandbox to do that. But at a certain point, the chaos starts to build. And so you can't predict too far into the future. Really, I think only just like a few hundred years, maybe a few thousand years, I think after a while, it's too hard to actually know precisely when, to be able to measure the orbits of the planets out beyond a certain point, because they're influencing each other. It's this very complicated orbital interaction. But yeah, if you're a programmer, I think there's a Python library you can run that will let you calculate planetary distances. Bobby Reynolds, is the Great Attractor like a big black hole? Not exactly. So the Great Attractor is a bunch of galaxies. So we've talked about this a bit in the past, and people are always fascinated. But it's like people are fascinated by a mystery from the 1970s, right? Who shot JR? Was it the 80s? Anyway, so the Great Attractor is, astronomers were mapping out these galaxies. They're mapping out essentially the expansion rate of these galaxies. And what they noticed was that a bunch of the galaxies on one side of the sky, essentially on the other side of the Milky Way, were all sliding towards something that had gravity. So, but the problem was, whatever that thing was, it was obscured by the core of the Milky Way, which is covered with gas and dust. And so astronomers didn't know. And so they called that region the zone of avoidance, which just meant don't bother pointing your telescope there, because you're just going to see, the gas and the dust is going to get in the way, and there's going to be nothing to see. But then astronomers developed infrared astronomy, and infrared astronomy allows you to see through the gas and the dust. Essentially, those molecules don't block infrared radiation, and now suddenly you can see through the zone of avoidance and see what the Great Attractor is. And what the Great Attractor turned out to be was galaxies. And it's, obviously that the Milky Way is part of this super group of galaxies, and all these galaxies are orbiting around like buzzing bees around the center of mass of all of the galaxies. And it just happened to be that the way the Milky Way is oriented, the center of that mass happens to be lined up with the way the Milky Way is, and we happen to be on the other side of the Milky Way, so that we can't see it directly in visible light. But now we can see it in infrared, and it is just a bunch of galaxies. Now, those galaxies, each one of them probably has a supermassive black hole at the heart of them, so there's a lot of black holes in that direction. But no, the mass that is pulling all of the galaxies in, and that's not even like the great way to say it. It's not like it's pulling them all in. It's more like they're all orbiting this common center of gravity, this common center of mass. And it just happens to be that we're unlucky in being able to perceive it, just because of how the Milky Way is aligned and where we are on the Milky Way, right? If we were on the other side of the Milky Way, no problem. The whole sky would be the Great Attractor. But in our case, we're on the other side. But if you could see the Great Attractor, it would just look like a bunch of galaxies, which is how it looks when you use infrared astronomy. So it is funny to me that this mystery is solved, right? Like we have the instruments now, which is these incredible infrared observatories that allow us to peer through that gas and dust and see what the Great Attractor is. It is no longer a mystery. In fact, we can perceive the individual galaxies in that region. So, Doug Ellis, is there a speed limit using gravity assist? No, in theory, there's no limit. I mean, obviously the speed of light, but if you had black holes orbiting other black holes and you attempted to do a gravity assist with one of these black holes, you could be accelerated to eventually up to the speed of light, or almost the speed of light. But of course, the problem is that you would be, as you're coming around the spacecraft, you're getting closer and closer to the thing that you're being accelerated by, you're going to experience all of these tidal forces. But the limit is really how close can you get to the object that you're being accelerated by. If you get too close and the gravity is too strong, then it'll tear you apart. So that's kind of going to be your limit. But you can do multiple flybys, build up your speed, and you could do flybys past star system after star system in the Milky Way, building up your speed faster and faster and faster. And if you can line up a bunch of black holes, that's the best. Julius Stanionis, why are there so many red dwarfs compared to other stars? Is it because red dwarfs live longer or because more of them are forming? If so, why don't stars follow normal distribution? Yeah, so there are way more red dwarf stars. Like the vast majority of the stars in the Milky Way are red dwarf stars. And so why are there more of them? And you talked about it. It's the normal distribution. So the normal distribution is smaller stars. It's the stars that we can see, the stars like our sun, etc. They're on the outliers. They're actually the bigger stars. The vast majority are the smaller red dwarfs and even like the brown dwarfs. So, and it's just that we don't see them in the sky. So if we could see the sky and see all of the red dwarfs that were in the same kind of region as the bright stars that we could see, the sky would look totally different. Like you can't even see some of the closest red dwarf stars with your unaided eye. You need a telescope to see like stuff that's just like Wolf 359, right? Like Proxima Centauri. You need a telescope to even be able to see them because they're so dim. And yet there's so many of them out there, the vast majority. And it's just that our perception is wrong because we see, like when you look at stars in the sky, you're mostly seeing stars that are much more massive than the sun, and they are very far away in most cases. They are, say, tens of light years. They are hundreds of light years. In some cases, they're even thousands of light years, which normally, if it was a red dwarf star, you wouldn't be able to see it even with very powerful telescopes. But it's because these are supergiant stars that we see in the sky. So pretty much every star that you can see in the sky is kind of special, very bright, very unusual. And that's all we can see are the unusual stars. Emily Brady, did the Big Bang happen in one place? No, the Big Bang happened everywhere, in every single part in space. The Big Bang happened where you're standing. The Big Bang happened where I'm standing. And the Big Bang happened everywhere in the universe. And so we talked about this last week. We'll keep talking about it. But the important thing to understand is that it is not an explosion that happened in one location. It is this expansion. And in the beginning of the universe, maybe the universe was infinite and just went on forever. But the distance between every spot in the universe just started to expand. Why? We don't know, but it did. And so now regions in space that a long time ago, right at the beginning of the universe, were centimeters apart are now light years apart. But that happened everywhere, to every single part of space. Whoa. It's a good question, but I don't know the answer. T-Home. Do you know a good map of the solar system's magnetic fields? The Parker Spiral, interplanetary magnetic field, etc. I don't. There was a new map that just came out of Mars's magnetosphere. I think it's on NASA's website. We just had an article on Universe Today about it, which is pretty great. So definitely go and check that out. But no, we only really know, each individual place, like Jupiter's magnetic field is mapped, Earth's magnetic field is mapped, but it also changes all the time, right? So the magnetic field grows and shrinks depending on the power, like how strong the solar wind is, the orientation of the planet. There's a lot of different factors. Detonks 333, just for fun, what would you rather use for exploration? Enterprise, Doctor Who's TARDIS, Stargate, or the Back to the Future DeLorean? The Stargate, absolutely. I would choose the Stargate, right? Because you just get to walk. And now you're in space. You're on another planet across the Milky Way. That would be the best. You don't even have to put on a spacesuit. You just walk. So I would love the Stargate. That would be my favorite. Visto Tutti, will you be able to star party the conjunction of Jupiter and Saturn later this year? Absolutely. Yeah, that's going to be incredible. Like one of the biggest moments, I hope you guys know, one of the biggest moments in astronomy, in visible astronomy, is going to be this conjunction between Saturn and Jupiter. I forget the exact date. It's in later on in this year, October, November. Anyway, Saturn and Jupiter will be so close, you'll be able to see them in a single telescope field of view, which is just going to be crazy. That you will look through the telescope and you'll see both Saturn and Jupiter side by side at the same time. It's going to be one of the most incredible views that we've ever had. I would say this is going to be as exciting as seeing the transit of Venus, right? This is just going to be mental. I can't wait. So yeah, we are going to pull out all the stops and do what we can to try and live stream that. Bobby Reynolds, are there stars out there bigger than UY Scuti? So probably. There are, I mean, every couple of years, astronomers announce a bigger star. And so what's UY Scuti is, how big is it compared to the sun? Scuti? Let's see. What, it's 1,200, 1,000 times the size of the sun? Anyway, we did a video. I did a video a couple of years ago, and I said it was VY Canis Majoris, and then the largest star changed, and so it's sort of crazy to not, to have to do that again. But I actually talked to a astronomer, and she was telling me that the largest possible star is about 1,500 to 2,000 times the size of the sun. So you would have a star that extends out beyond the orbit of Saturn, almost out to the orbit of Uranus. And that's just like a single star. So as we explore more and more of the Milky Way, we will continue to find the biggest, star, but it'll be the biggest star so far, and then we'll find a bigger one. And theoretically, we can keep finding these biggest stars until we get up to about 2,000 times the size of the sun. Tromedia, is it possible for a large moon to have its own moons? Yeah, in theory, it's possible for a moon to have moons, mini moons. We don't know of any in the solar system, but theoretically, Neptune could have a moon, like a big moon like Triton, and Triton could have its own moon as well. So theoretically, and in theory, its moon could have its own moons as well, right? All of the galaxies all the galaxies around us are orbiting around the local group, or actually they're all rotating around the Virgo supercluster, and then all the stars are orbiting around the center of the galaxy, and all of the planets are orbiting around the star, and all of the moons are orbiting around their planets. And right now we have spacecraft orbiting around the moon. So I guess you could say the moon has its own moons. So there's no reason why, but the reason why you wouldn't get them is that essentially you get all of these gravitational interactions between all of the objects that make these orbits unstable. And so if the moon had a moon of its own, the Earth would be trying to steal it or wreck the orbit. So it's only when the moon is far enough away that it's barely influenced by the planet, and it has a moon that's of the right size, then you could have it to be stable. So we don't know of any, but in theory, yeah. All right. A bunch of people put this in, so it's December 21st. There you go. So that's when we will be live streaming as best I can this conjunction. It's going to be incredible. We'll just point as many telescopes as we can get our hands on and point it at this conjunction and just enjoy a once in a lifetime situation. Ooh, Dustman, what was the best iteration of Star Trek? Well, Star Trek II: The Wrath of Khan. And then I'm going to go with Star Trek: The Next Generation. Would be my favorite Star Trek stuff. In fact, it's funny, my wife and I are rewatching all of the Star Treks, and we're just in Deep Space Nine right now. And I actually never finished watching Deep Space Nine, but I hear it's super good by the end. But in the beginning, it's so mediocre, and we're just toughing our way through it. But I hear it gets much better. So I would say so far my favorite is The Next Generation. When I watched it, just blew my mind. It was so great. I loved it so much. L disk. Does the moon have Lagrange points too? Yeah, you don't. Any object doesn't have Lagrange points of its own. You have to have two objects to have Lagrange points. So in other words, there are Lagrange points between the Earth and the sun, and there are Lagrange points between the Earth and the moon, and there are Lagrange points between the sun and Jupiter, and there are Lagrange points between Jupiter and Europa. There's always going to be 5 Lagrange points between any two objects. So yeah, the moon has Lagrange points in that it has 5 Lagrange points with the Earth. Nancy Graziano says we're binging on DS9 for about the 10th time. Okay, Nancy, when does it get good? Because right now it's not good. We're at like episode 15-ish in the first season. And I remember watching a bunch of these. I think I made it to the 3rd season or so before I started to, I just got sick of it. But I hear it gets better as you get into more of the Dominion War. So tell me when Deep Space Nine, like just so I know what the finish line is for when it gets good. Arjun, will the Virgo supercluster keep together or will it fall apart in time? Yeah, so that, people say that the Virgo supercluster, or now they say the Laniakea supercluster, is the biggest object, biggest structure in the universe. But the problem is that the expansion of the universe is carrying various pieces of the universe apart, of the Virgo supercluster apart. And so it's not really accurate, although, they are connected through gravity. They are slowing each other's mutual expansion away from each other a certain amount. It's not exactly accurate to say that they're one thing, because in the end they will be torn apart and they will be scattered across the universe. So no, large chunks of the Virgo supercluster won't be kept together. They will eventually end up. It's really only the local group with Andromeda, with M33, and with a bunch of the dwarf galaxies that surround us that will end up as one big galaxy by the time this is all done. And eventually the supercluster will be scattered to the 4 corners of the universe. They will fall over the cosmic horizon, and then we will forget the time when we considered we were in the same neighborhood as them. Mr. Tommy Pickles, what's your favorite artificial gravity system? I don't know. How do you define it? Are you talking about realistic ones? There's really only one realistic artificial gravity system, which is rotating space stations, things like that. Constant acceleration would be wonderful, but it's impossible because you don't have enough propellant to maintain constant acceleration forever, like they do in The Expanse. Magical science fiction artificial gravity systems, I don't know, they're all the same now. The grav plates, whatever it is that keeps gravity on your spaceship, those are the best. Bobby Reynolds, could aliens from other planets smaller than the Earth feel the weight different when they come to Earth? Absolutely. If aliens come from a place with lower gravity, then when they come to the Earth, it will feel hard for them to walk around. It'll be like they would have evolved in a place where they didn't need to have as thick bones, as strong muscles. They would have a really hard time being able to walk around on Earth gravity, and vice versa. If aliens come from some really heavy gravity place and they came to Earth, then suddenly it would be very easy and they would be jumping around and they would be having a lot of fun. And the equivalent is when astronauts go to the moon and they experience being in 1/6 gravity. We evolved in this stronger Earth gravity, and now suddenly we're in a place where our muscles are way too strong, our bones are way too strong for this lighter gravity, and so we can jump really high and bounce around in this place. And so it would just be the exact same experience for the aliens, but they would be incredibly strong. Let's see. Gwym, for curiosity's sake, what's your favorite snack? Watermelon. I love watermelon. Sergio Botero, besides one Bob and one Doug, what did the Crew Dragon take to the ISS? I don't know if Crew Dragon was carrying anything other than the astronauts. I actually don't know. Donacha McGeever, are we in a new space race? I think so. The space race, of course, is sort of like a multi-group space race at this point. There are the people there's the countries. So China is absolutely in a space race with the rest of the world. They are building they've built their heavy launch Long March. They are working on their own version of the space station. They are testing out technology that's going to take them to the moon. Within the next decade, we should see China land on the moon. So if the United States can meet their 2024 deadline, then they will have beat the Chinese back to the moon. But it's not just China and it's not just America, right? You've got the private groups like Blue Origin and SpaceX with the Starship. I mean, in theory, by 2022, Starship will fly from Earth and land on the moon and then just return. Of course, we just saw the SN4 explode. What's that now? 4 of them? 5 exploding starships? I mean, that's what they do, is they explode until they don't. But I suspect we're going to see a bunch more prototypes detonate on the launch pad before they have mastered this technology. And of course, because it's hard and it's new and space is hard. Bobo Kitty, why use artificial gravity when you could incorporate a moon within the core of a spaceship design? Well, because then you have to move a moon around, right? In terms of changing the velocity of your spaceship, you want it to be as light as possible so that it requires the minimum amount of propellant to be able to move your spaceship. If your spaceship is a moon, that's a very expensive, very propellant heavy design that you're going to be creating. And you would have some gravity, but you couldn't really compact a moon down so that you could use it in any way. I mean, really, you're just living on a moon, and then you go where the moon wants to go, which is mostly around and around whatever it's orbiting. JM Autobot, why is it called a race all the time? Can't we just have concurrent nations and organizations with space goals? Seems silly to call everything a race to you. Because it's a race. It is a race. Now, there is, back in the original space race, there was real, like when the Soviet Union launched Sputnik, it was this announcement to the rest of the world that the Soviet Union was a serious, powerful nation that should not be trifled with. They have power over the space domain. And then they went on to launch humans into space and more complicated missions. And that's even scarier. And so there is something to be said for racing to achieve that kind of, unfortunately, right? It's really military dominance. Who can capture the high ground, with space being the ultimate high ground? And so the way that you prove that you are a capable modern nation is you have a space program. And there are all kinds of benefits. Obviously, you have navigational satellites and communication satellites. You have weather satellites, and you do scientific research and all that kind of stuff. But at the end of the day, there's a lot to be said for demonstrating to the world that you are a serious contender. It shows that you have a stable economy to a certain extent. It shows that you have scientific capability. You are a place that's good for investment. So there are all kinds of benefits to being able to have that kind of capability. So I think it is a race, and I think there is there's a certain, with China demonstrating its ability, it is causing America to speed up its process of being able to get Artemis going. I'm sure there was an incentive going. The Chinese are definitely going back to the moon. So that's why I think that's part of it. So it is a race. Like, you might not like the term, and obviously that's not what we want. We want an international collaboration of people that go for mutual scientific study of space. But this is the way that nations can demonstrate that they've got their act together and they are technologically capable. So get used to it. Unfortunately, it sucks. I know. And sometimes a race is a good thing, right? Sometimes that having a deadline, having some kind of competition helps us bring out our best, as long as it's done peacefully. I think there's value in this. It's not a bad thing. Someone was asking what I thought of, there you go, Neil, you wants to know what I thought of Space Force. Would I do a reaction style video? Probably not. It was fine. I liked it, Space Force. I mean, I had to take everything I know about space and just tuck it away and not let it inform my opinion of the show, but I enjoyed Space Force a lot on Netflix. It was funny. It was charming. There was lots of great characters. There was lots of stuff that was very accurate, and there was lots of stuff that was ridiculously inaccurate that they really just had to ask one person to go, is this how it would work? And they would go, nope. But they could have given them an answer that would be correct. So, but definitely watch it. I'm not very, I don't need my science fiction to be scientifically accurate. I have no requirement for that. Grant W. How might territory ownership be allocated to nations on the moon, Mars, etc.? Is war inevitable? I hope that war isn't inevitable. The space is very valuable. But the thing that space is pretty much most valuable for is your ability to essentially destroy your enemies at a moment's notice. And this is why the Outer Space Treaty was signed in the first place back in 1967, was because people knew that if you could put a nuclear weapon system into space and it would just be orbiting, then at any point, so imagine like Starlinks right now. Instead of Starlinks, you had nuclear weapons pointed at your enemies. Then at the drop of a hat, you could press a button and one could fire a nuclear weapon down at your enemy. Within 5 minutes, you would be starting to destroy their cities. And that was a terrifying concept. And they all agreed that they would much rather have it take 45 minutes for your missiles to cross from continent to continent. And so they all signed the Outer Space Treaty. That is the purpose. That is the thing that everybody's afraid of, is that you will be able to destroy each other with weapons from space. Is war inevitable? I hope not, right? As we move forward with our technology and our advancement of human society, wars are less common around the world. There's less war happening this year than happened last year. There's less war that happened last year than happened the year before. And so we hope that as we all become more wealthy, as our society becomes more equal, then there won't ever be a need for war again. But you never know. And if you want the ultimate high ground, it's space. So that's why there's always going to be military interest in space, and that's why there is an actual thing as a space force. It is inevitable. Let's see. James T. Should we have our first Mars colonists living slightly underground to combat the radiation? Yeah, I wouldn't say they'd be living slightly underground. I say they'd be living entirely underground. You want to put a couple of meters of rock between you and space to protect you from the radiation in space. So, yeah, absolutely. That's going to be your life. So imagine living in Antarctica, except underground all the time. That's what living on Mars will be like. Every now and then you'll be able to walk outside with a spacesuit and appreciate the red mountains and sand and lava flows. So, Girish 1, is James Webb too big to fail? Well, at this point, James Webb is too finished to fail. Essentially, the telescope is done. They're doing the final fold-up tests. They're going to be packing it up and sending it on a barge to get launched. So a lot of the budget gobbling part is behind us now. Back 5-8 years ago, when it was really expanding in terms of the complexity, and that was because they were taking on a lot of technical challenges all at the same time. At this point, I think it is it's done. It's ready to pull it out of the oven and throw it into space. So at this point, I think it's absolutely, I mean, the sunk cost, it is literally the very definition of the sunk cost fallacy when you look at $10 billion being spent-ish to build this telescope. And you imagine you could have had multiple 100-meter telescopes, ground-based telescopes that could have been built for the same amount of money, or multiple replacement Hubble Space Telescopes. But this was what got built. But sometimes, anyone who's worked on a project knows that sometimes the project just gets bigger and bigger and bigger as you're working on it. And it's really hard. And the more technical uncertainty you put into the project, the more complicated it gets and the more expensive it gets. And so hindsight is 2020, and I'm sure the engineers would love to go back and replace chunks of technical uncertainty. But you're seeing the lessons learned on other projects. You're not seeing WFIRST make the same mistakes. You didn't see, you're seeing a lot of other missions come in on time, on budget. Not the Space Launch System, but again, I mean, the Space Launch System, when you see what happened with the Crew Dragon launch, just shows how much of a value, how valuable commercial space is at this point. And of course, assuming starships will stop exploding at some point in the future, they will be a very serious contender for the Space Launch System. Kate Pepper asks, speak of Netflix shows, what was your opinion of Mars? I don't know if I saw Mars. Was that the one where people were trying to, the first human exploration of Mars, the National Geographic one? There've been so many. When you get to choose a reasonable space project for Canada that fits its budget, what would you like to see done? Obviously, I want to see robotic arms on everything. That's the proper Canadian response. No, I mean, like, what's a Canadian budget? I mean, let's say our budget is a couple of $1 billion, maybe $1 billion. That's like a couple of smaller spacecraft, right? So I would probably want some very specialized planet, like exoplanet observation spacecraft, like the kinds of things that they do with, like the Gaia mission is great, or the Large Synoptic Survey Telescope, these big surveys that can be used for various things. Canada actually has a space telescope. It's called MOST, and they always call it the Humble Space Telescope because it costs $9 million. And it actually does a great job of observing variable stars and can even find planets. So I'm a big fan of fairly low cost telescopes, missions that can solve some interesting problems. I would probably, fund a Finnish electric sail or something. That would be cool. So, I really feel that government's job is to help solve the unknown, solve the kinds of problems that private companies just can't do. And then, so to remove technical uncertainty, but then let the private industry take the ball and run. So whatever it is that they are afraid to tackle, that's, I think, what the role for government is. Once the private industry feels pretty confident about it, then the government should get out of the way and let these private companies build the kinds of rockets that they want, or the kinds of, those kinds of technologies. Do Bob and Doug have robotic arms? Yeah, I have to say Bob and Doug, of course, people of the right age can remember that Bob and Doug are the names of characters from a Canadian television show that played in the US. Anyway. Eric K., why have we not sent any spacecraft to Uranus or Neptune? Is it not worth the cost? It's just lower on the priority list. There have been a couple of missions that have been designed to go to Uranus and Neptune, but none have actually flown. But I think that we're going to see in the next, when you think about it, only Voyager 2 has only done a flyby of Uranus and Neptune, and yet these are the number 3 and 4th largest planets in the solar system. They all have very complicated, interesting moon systems. They have rings. Something weird happened to them in the early stages of the solar system's history. Like, we've got to go and learn more about these, and yet we don't. So, I think that if I was to sort of consider priorities, obviously I want to see Europa, and that's what the Europa Clipper is going to do, and JUICE. I want to have a mission back to Titan, but that's going to be the Titan Dragonfly. I'd like to see some missions back to Venus. But then I would say, yeah, a mission to Uranus and Neptune. 1 or 2 if you can. That would be great. Arjun, starships are exploding left and right. Is Blue Origin doing stuff in secret? Yeah. So Blue Origin is working mostly in secret. We don't know really what Blue Origin is up to. We see the New Shepard launch, and it goes up to orbit, and then it lands on its launch pad again, which is very impressive, right? They are essentially demonstrating that they have the ability for vertical launch and landing. And then at the same time, we have seen the specifications for the New Glenn, and it's a very large rocket, right? Has more launch capacity than the Falcon Heavy. So it's a monster in a fully reusable format. But we haven't actually seen this thing fly. We haven't even seen this thing anything other than an artist's rendition. And yet we're to believe that we're going to see them launch next year. That's without tests yet is very impressive. And then we watch SpaceX really trying to understand how to make something super heavy fly like the Starship. So on the one hand, I highly respect Blue Origin's ability, the stuff that they've demonstrated and the plans that they put on paper. But the plans that you put is a far cry from demonstrating that your hardware works. And so I have a ton of respect for seeing these prototypes explode as SpaceX is figuring out all of the complexities to create a fully reusable rocket system. That is the leapfrog. Like, New Glenn is a very large reusable rocket system, but Starship is next level, right? Because the whole thing is reusable and the scale is incredible. And so if they can crack it, then they have completely jumped anything that Blue Origin is able to do. And even if Blue Origin is working on their replacement called the New Armstrong, I'm not sure whether it's going to be a fully reusable rocket either. So I think there's value to working privately, but I think there's more value to working publicly. And so I think in the case of Blue Origin, it's a mistake to work this privately. They're losing all of the brand. They're losing all of the free publicity that comes from people being so excited and watching what happens. And I think people are excited about what SpaceX is going to do next, despite the the negative press that's happened at the same time. So I think it's a mistake. If I was Jeff Bezos, I would be running the whole company with far more transparency. Like what do you have to lose, right? Like, is someone going to steal your idea of a really big rocket? So, but it might just be that they're just not ready, that they're just waiting, they're testing all the pieces and they're just not there yet to be able to actually demonstrate the capability of their new launch system yet. And maybe we will see that. I mean, you're seeing the new shepherds prove that they can fly and land and fly and land. I mean, have there been any New Shepard crashes? Have there been any mistakes yet? I don't think so, right? So far, the system is working perfectly, but now we just have to see the scale. Arjona is saying that Isaac Arthur just got married. He looks so happy. Congratulations, Isaac. That's awesome. Medievalists. I've been enjoying Science and Futurism with Isaac Arthur. You've talked to him before. What are your thoughts about his videos? I love his videos when I have time to watch them, but I don't have time to watch anybody's videos. But yeah, if you're looking for some other like if you're enjoying the content on my channel, absolutely go and check out Isaac Arthur's videos. I mean, I like to stick to the near future, the stuff that's happening right now, but Isaac Arthur is great to just think of the stuff that's just like to the very ends of time, to really let your imagination fly. And I have mad respect for someone who's trying to figure out how you would colonize Neptune. So, yeah, they're super fun videos. And he's very regular in his production schedule, and the production value is just getting better and better and better with every episode. So yeah, absolutely. If you haven't already, go check out Science and Futurism with Isaac Arthur, as well as, of course, Everyday Astronaut, Tim Dodd, Scott Manley, Joe Scott. There's a lot of great, and there's a whole bunch of other channels here on YouTube who are doing a fantastic job of space and science explanations. Dr. Becky, man, there's so many. So, yeah. Bobby Reynolds, you asked me who would win, a black hole or strange matter. I have no idea. I guess, in theory, if strange matter gives you the ability to bend space and time, then you would be able to dismantle a black hole. So I guess in theory, strange matter would let you do that, but then it all just depends on how it works and what it is. But essentially, if you can create negative mass, then you can dismantle black holes. There you go. PBS Spacetime is another recommendation. Check that out as well. Yeah. Gwim says, wouldn't a walking robot be superior to a rover over rough terrain? Should we invest in some Canada legs? Yeah, we totally should. I love it. Canada legs, Canada arms, Canada legs. We'll build all the limbs for all of your spacecraft. Yeah, there's some great ideas. There's an episode that's sort of half written that we're working on, which is what I'm calling weird rovers. And they've got there's ones that roll on the underside of ice, like on water, in water. They float and then they roll along on the underside of an ice sheet. There's snake bots that can sort of slide their way into crevices and lava tubes and things like that. There are jumping robots and flipping robots and stuff. And there's various versions of walking robots. So at some point, we're going to kind of gather together all of these wacky rovers, set it to yakety sax, and do a video of this. So. Oh, there you go. Larry Beckham. Strange quarks are not negative mass. They are heavy. Right. So you need negative mass. If you want to take apart a black hole, you have to have negative mass. Oh, yeah. Arjun says last one. Christian Reddy, Launchpad Astronomy. Agreed. I mean, there are dozens of fantastic space-related channels here. All right. Okay, well, I think we've reached pretty much the end of our hour. So we probably will have a new episode about the Crew Dragon mission. And sort of half of it is just giving you an update on Crew Dragon. The other half is the history of the commercial space program and how we got to this point and some of the trials and tribulations and the funding and such. So that should probably come out, I'm guessing, Wednesday. And then probably another QA show this week, and probably another episode after that. So there's a ton of news. So if you haven't already, definitely sign up for my newsletter. I send that out every week. It's got dozens of space stories. There's no ads in it. It is like as much quality content as I can generate. And I write them all personally by hand. So you should definitely subscribe. Go to universetoday.com/newsletter. All right. So thank you everyone who answered questions. Thanks to all the moderators who were copying all the questions so I could read them. Thanks to everybody on Twitch as well as on YouTube. It's great to have everybody following everything that we're doing. And we're going to have a special guest, I think this week, at a funny time because he's in England as well. But I will give you an update on that when it happens. So again, thank you, everybody. The next thing that's happening is the weekly Space Hangout on Wednesday at the same time. So we'll see you then if you want to join. All right. Thanks, everybody. Take care. We'll see you next time.